Greetings and welcome to Distillate. So today we'll be learning how to access list elements. So we suppose we have a lot of data stored in a bunch of lists, but in order to perform some operation on those data sets, we'll have to actually access those elements from the list and then let's say add them or subtract them and so on, right? So in order to access any list element, we need to learn about indices, list indices. So if I have a list, so let's say my list is something, 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 right? So it would have some sort of indices. And these indices start with 0. So the first element of the list, which is basically the first entry of the list, that is going to be having an index of 0. Then the next element will be having an index of 1. And so on. It will go on till whatever is the length of the list minus 1, because the indices start from 0. So if the list has, let's say, 10 elements, then the last element will have an index of 9. If the list has 3 elements, so the last element would have an index of 2, right? So this is how you can access list elements from the left. So starting from the first element with an index of 0, we can access all the elements, right? But let's say if I want to access the elements from the end, that can also be possible. So we can do that by using -1. So -1 is basically the index of the last element. So if the first element has an index of 0, we move behind it. So we basically reach here, which is the last element. So the last element has this index and it can also be represented by this. Similarly, the second last would be this. Third last would be this, and so on. Okay, this is very challenging. Okay. Yeah. So we could go on till we reach the first element, and the first element would have the index of minus len list, right? So let's try to understand this with an example. So over here, I'll have a list 1, 2, 3, 4, right? And now if I want to access the element with an index 0, so I'll write the name of the list, L. Within the square brackets, I'll write the list, the index of the element which we are trying to access. So L is the name of the list. We've written it here. And within the brackets, we have written 0. So this would access the element with index 0, which is this element. Okay. So that's 1. Similarly, this is 2, 3, and finally the index with, element with index 3 is 4. So it will access that. Now let's say we want to go back. We want to start from the right. So this would give us the last element, which is 4. So L minus 1 gives us the last element. L minus 2 gives us second last element. L minus 3 gives us third last element. And L minus 4 gives us the last element. Sorry, the fourth last element, or basically the first element in our case. Okay. And yeah, so this is how we can access elements in the list starting from the complete left or starting from the complete right. If you are starting from the complete left, the first index is going to be 0. If you are going to start from the extreme right, then the first index would be -1. Okay. So let's now perform some operations on this particular list. So let's say my first objective is just to print all the elements in this list. Okay. So I'll say for I in range length L. So what is the length of L here? It's 4, right? So we are basically typing for I in range 4. That means the allowed values of I are 0, 1, 2, and 3, right? So this I basically is a variable which is assigned to the indices of the list in our code, right? So since 0, 1, 2, 3 are the allowed indices, it would cover all the indices of this particular list. All right. So now I'll just print li. Okay. So when I would be 0, it will print the first element, or basically the element with index 0, and so on, right? So if I print this, so we'll get 1, 2, 3, 4. All the list elements have been printed. Okay. Let's say we want to do some other operation. We want to make another list with uh, the values such that the values of all the elements in the second list have to be the values of the elements, corresponding elements in this list plus some A, right? So we'll decide a value of A here, and we'll make an empty list here. And then we'll say L1 dot append Li plus A. So what we are doing is we are making another list and assigning basically appending in each iteration, we are appending the ith element of this plus 2 to this list, right? So if we print this list L1 towards the end, we'll see that we have 3, 4, 5, 6 here, right? And if I print the list L1 inside the loop itself, so we'll see how the list is actually being formed. So the first list, the first iteration just appended this plus 2. Then the second iteration appended 2 plus 2, and so on, right? So we've got the second list over here, right? Another way could be that, you know, you make up a list of any 4 elements, right? Let's say 0, 0, 0, 0. And instead of using the append command, you can actually simply assign the ith element of the second list as the ith element of the first list plus A. So now what we are doing is, when I is, let's say, 0, I am accessing the the index with, sorry, the element with index 0, and I am setting its value to L0 plus A, which means I'm setting its value to 3, right? And the rest of the elements in this entire list remain the same. So that's 0, 0, 0, 0. So when I print this in each iteration, you'll see for the first iteration, only the first element got changed. In the second iteration, the second element got changed, and so on, right? So one major difference in the first method, the append method, and the second method is that in the first method, the list size kept on changing with each iteration. While in the second method, the list size was the same, just each iteration was updating a new element. All right. So these are the two methods which you could use. There could be many other methods. These are the two that I would be using very often. Yeah. Okay. So this has been done. And now let's say we want to plot these two. So I'll just have import matplotlib.pyplot as plt. and then I'll plot the two. So let's say I want L to be in the x-axis. So L, comma L1, which I want in the y-axis. And naturally, it's going to be y is equal to x plus 2 over here. So this is just going to have an intercept of 2. And I'll just run this. And over here, I can see a straight line, right? Let's say I want to have a parabola. So in that case, I will say, let's say I want the elements of the list L1 to be x squared plus a. So the squared term comes like this. So we can perform all the operations we've learned on integers on these lists, the elements of the lists by accessing them using the index, right? So this helps us get a parabola. And as I told you, the more data points you'll have, the more smooth this parabola would look like, right? Uh, so yeah, we can do a lot of operations with this, right? Let's do some cool math problems or basically some statistics using lists. So for example, we have the list L over here with us, right? Now, let's say we want to get sum of all elements in the list, right? So what we are going to do? So in a normal way, you would just say that S is equal to 0. Then you will take the first element, add it to this S, then take the second element, add it to S, third element, add it to S, and so on. So we'll do the same. So this gives the value of each index to I. This accesses the ith element, and this adds the ith element to the existing value of S. So this is how we calculate sum of a range of numbers. And this is what we are doing here as well, right? The same operation that we were doing on integers or any whole number, right? Any rational number, sorry. So when I print the sum S, I have the sum over here, right? Now, an easier way to actually do this is by using the sum function. So this is how we calculate the sum, but an easier way would be just to use the inbuilt sum function. So if I type sum and within the brackets L, and let's say I store it in this variable S, and then I'll print the variable S, right? So this does the exact same thing. It adds all the elements of the list. All right. So we won't have to type these 3 lines, and rather we would simply get the sum in one single line, right? So this is actually very, very useful for especially more complex problems where you do not want your uh, code to exceed multiple lines. So this actually becomes very helpful. And this actually also gives us an introduction to what is called as functions, because as you see, if we have to write the same command multiple, let's say I have got this list L and we are calculating the sum of all the elements of the L list L right now. But let's say we have 10 lists and we have to calculate the sum of all elements in the 10 lists. So we have to write the same command or the same 3 lines 10 times. So rather than that, we'll just write this one line 10 times, right? Or even better, we'll run that in loop, so that makes our code even shorter, right? So this actually helps us a lot, and you will see later on how, but this is very, very helpful using of functions, right? So later on, as we define functions, we'll realize how useful this actually is. Okay, so anyway, this is a way to calculate the sum, and this is what we'll be using now onwards. So we'll not be using the for loop method for calculating sum of elements in a list. Now let's do some statistics with it. So let's say we want to calculate the mean of all the elements that are there in this list. So mean is just sum of all elements divided by the number of all elements. So I'll just write sum L, which gives me the sum of all elements divided by len L, which gives me the number of elements in the list, right? So that gives me the mean. And the mean of this is 2.5, right? Now let's say we want to calculate the variance. So how to calculate the variance? Variance is basically each element. So first we'll take the element x, we'll subtract it by the mean, take a square of that, and add these sum of squares and divide it by the length. That is the variance. So I'll just write the formula here. Variance is equal to sum of xi minus x bar square, right? Whole divided by, I'll just use these parentheses below, the number of data points. So xi represents individual data points. So if let's say we have 1, 2, 3, 4, and our mean is 2.5. So xi means 1 minus 2.5 whole square plus 2 minus 2.5 whole square and so on, right? So that's how you calculate the variance. And now we can do that by calculating the sum as we do normally, right? So for I in range len L, and then once again, this accesses the ith element. This subtracts the ith element by the mean. This takes the square of this difference. And this adds this value to the variance. And remember, that is not the end. We have to add all of these and divide it by the length. So this gives us the variance, right? So if I print variance, let's say, I'll be able to get this value. So 1.25 is the variance of this, right? And in order to calculate the standard deviation, I'll do the same thing, just it's the square root of the variance. So in order to calculate the square root, I need the math module. So this is going to be math dot square root of the variance. So that's how you calculate the standard deviation. Okay. So similarly, we can do a lot of cool statistical analyses for our given data set using Python, right? Although there are inbuilt tools, but you'll now understand how the functioning of these tools can be done. How do you code these tools, and you would be able to write simpler code using your own method, right? Let's do a simple chemical engineering specific example. So let's say I have moles of, let's say, five compounds in a list, right? So let's say I have 10 moles of A, 12 moles of B, 11 of C, 5 of D, and let's say 3 moles of E, right? And now let's give their molecular weights as well. So I'll make another list, MWT, and the molecular weights of this is, let's say, 100, 20, 50, 10. 10 is okay, too low. Let's take 40 and let's go to 60, right? So let's say these are the molecular weights of, let's say, A, B, C, D, and E. So corresponding molecular weights, right? And let's say we want to calculate the mole fractions. So we know, chemical engineers would know, that mole fraction is the individual number of moles divided by the total number of moles, right? So the total number of moles we can get by adding all the moles in the individual moles list, right? So by adding all of them, we'll get the total number of moles, right? And then to get the mole fraction, um, the mole fractions of each element, we'll make an empty list and then we'll append something to it, right? So what will we append? So let's just access everything. So this gives us the moles of the ith index, right? This divides the total number of moles by the moles of the ith index. And we'll append this to the mole fraction list, right? So this gives us the mole fractions of each. So let's just print the mole fraction list. And when we do this, we have this list over here in front of us. And we all know that the sum of mole fractions has to be equal to 1. So let's check that. And that's 1, right? Now, let's say you want to calculate the average molecular weight of this gas stream or whatever, right? So average molecular weight is the mole fraction multiplied by molecular weight of that component, and that has to be added for all components, right? So average molecular weight is mole fraction multiplied by the molecular weight of that component, right? But this has to be done in a loop, of course. So I'll just copy this entire command over here and make an empty list, average molecular weight, right? And then again, for I in range, length of mole fraction list, right? And average, well, sorry, one second, sorry. So average, this, we are not making a list, we are just adding everything. So we'll just say average molecular weight is equal to 0. And then we'll add the individual mole fraction multiplied by the molecular weight of that uh, individual, right? And we'll add this for all the elements, right? So let's print the average molecular weight. And this is the average molecular weight, right? Let's say we want to calculate the mass fractions, right? So we have the mole fractions over here. Let's say we want to calculate the mass fraction. So in one of my previous videos on process calculations, I have given, in one of the beginning videos, I've given uh, a method of calculating mass fractions from mole fractions. So basically what we do in that is we calculate masses of individual elements by uh, multiplying the moles of the individual element by their by their molecular weight. So that gives us the mass of the individual elements. So let's make a list of masses. So let's make an empty list. And then again, for I in range, len, moles, right? Now what we are doing here is we are taking the moles of the ith element, multiplying them by the molecular weight of the ith element, and appending them to the list mass. So this gives us the masses of the individual elements, right? And now we have the mass list. So we get the total mass as the sum of all elements in the mass list, right? That is total mass. And finally, in order to calculate the mass fraction, we again have to make a list. We have to go in the range of mass list, right? Then this accesses the ith element of the mass list. This divides the ith element or the mass of the ith element by the total mass. And this appends it to the mass fraction list, right? And here we have the mass fraction list. Let's just see how it goes. And that is it, right? And let's again see if the mass fractions, they need to add to 1 and they are adding to 1, right? And let's say, just for fun, if we want to plot mass fraction versus mole fraction. So import matplotlib.pyplot as plt and plt.plot mass fraction versus mole fraction, right? So now we have mass fraction in the x and mole fraction in the y. And let's see how the plot looks like. So it looks like this, right? It looks like this. Has nothing to do with, I mean, this is not at all a trend. It's just plots everything together, right? Um, so yeah, um, this is how we could apply this basically to some of the chemical engineering problems. And we'll be doing more of this later on. But yeah, I hope you have now got some clue of accessing list elements, then uh, performing mathematical operations on them and doing some cool calculations with this, right? This can actually be very, very helpful for a large data set. So let's say you have multiple components. These were just 5, but let's say you have hundreds of components. Then this can actually be very helpful. You just need the data for the moles of that and molecular weight of that. And then you'll be able to get a lot of things, right? So hope this video was informational. I have again attached a self-assessment test for this. This is again very important and make sure you perform very well in this. If you have doubts with that, you can definitely mail me or add comments in the comment section of this video with any doubts, and I will try to address them as soon as possible. Fine. Thank you.